Our home, Earth, a small blue dot drifting in the vast cosmic ocean, is where everyone you've ever known has lived, every human who has ever walked this earth, and every story that has ever been told. It's where our journey begins. But as we pull back from our planet, beyond our atmosphere, past the moon, beyond the familiar planet and the sun, we embark on an extraordinary journey, a quest to truly understand the vast scale of our universe. The first step on our cosmic journey is the moon, roughly 384,000 kilometers away. This distance is so enormous that if you were to drive a car at a constant speed of 100 kilometers per hour, it would take you over 160 days to get there. From this lunar vantage point, Earth looks like a fragile sphere of blue and green, suspended in the dark void of space, offering a humbling view of our existence. This is how Earth appears from the moon. As we continue our journey outward, the next landmark is the Sun, located about 1 astronomical unit away from Earth, around 150 million kilometers. Imagine the light traveling at an incredible speed of 300,000 kilometers per second. It takes about 8 minutes and 20 seconds to travel from the Sun to Earth. If you were to fly this distance on a commercial jet at 900 kilometers per hour, it would take you roughly 19 years. This enormous distance reminds us of the immensity of space, even within our own solar system. The Sun, a fiery giant, supplies life-sustaining energy to our planet. From this vast distance, venturing beyond Earth and its solar companion, we aim for Mars, our intriguing red neighbor. Mars, at its closest approach to Earth, is about 54.6 million kilometers away, though this distance can grow to 401 million kilometers when the planets are on opposite sides of the Sun. To put that in perspective, traveling to Mars at the speed of a commercial jet would take more than 50 years. The vast space between Earth and Mars has presented a major challenge for space exploration. The rovers and probes we've sent to the Red Planet embark on a journey that is not only long, but also fraught with complexities due to changing distances and orbital dynamics. Moving further into our solar system, we come to Neptune, the distant ice giant, about 4.5 billion kilometers from Earth. Neptune marks the outer edge of our solar neighborhood. Sunlight takes about 4 hours and 15 minutes to reach Neptune, emphasizing the sheer scale of our solar system. Launched in 1977, the Voyager 1 space probe represents humanity's boundless curiosity and desire to explore beyond the known. Voyager 1 has traveled over 22 billion kilometers from Earth, making it the farthest human-made object from our planet, a silent voyager in the cosmic sea. In 1990, at the suggestion of renowned astronomer Carl Sagan, Voyager 1 turned its camera back toward Earth for one final image. This resulted in the iconic pale blue dot photograph, showing Earth as a tiny faint dot in the vastness of space. Carl Sagan poetically reflected on this image, reminding us of our responsibility to cherish and protect our only home, a tiny speck in the vast universe. At the very edge of our solar system lies the Oort cloud, a vast theoretical sphere of icy objects that could stretch up to 100,000 astronomical units from the Sun, or about 1.9 light years, a distance so vast it reaches the edge of interstellar space. Scientists define the boundary of interstellar space as the heliopause, where the solar wind from our Sun is stopped by the interstellar medium. This is where the influence of our Sun ends, and the vast expanse of interstellar space begins. The Oort cloud marks the final frontier of our solar system, a zone where the Sun's influence fades, and our cosmic journey into the galaxy begins. Venturing beyond the solar system, our next destination is Alpha Centauri, the closest star system to our Sun, located about 41.3 trillion kilometers away. Alpha Centauri is about 4.4 light-years away, and considering our current space travel technology, a journey there would be nearly inconceivable. For example, Voyager 1, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. This unimaginable distance emphasizes the vastness of space that separates stars and highlights the challenges of interstellar travel. Now, our journey takes us to the grand scale of our home galaxy, the Milky Way, which spans about 100,000 light-years in diameter. This vast spiral galaxy is home to hundreds of billions of stars, each potentially hosting its own planetary systems. Within this massive structure lies the human radio bubble, a tiny sphere extending about 100 light-years from Earth. This bubble represents the farthest reach of human influence, the extent of our radio and television broadcasts into space. Beyond this bubble, it is as if humanity never existed, and any civilizations residing in the majority of our galaxy would be unaware of our presence. The scale of the Milky Way is so vast that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. Leaving the Milky Way, we enter the vast and incomprehensible realm of intergalactic space, where galaxies drift in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of over 50 galaxies spread across approximately 10 million light-years. The distances here are so vast that light traveling from one end of the Local Group to the other would take 10 million years. This scale dwarfs anything within our galaxy and underscores the enormity of the universe. Intergalactic space is a silent expanse, a wilderness between the islands of galactic light. In this immense void, our galaxy, home to our entire history, is but a tiny speck among many, a single story in the grand cosmic library. Moving beyond the Local Group, we encounter the colossal Virgo supercluster, a massive collection of galaxy groups and clusters, including our Local Group. This supercluster spans about 110 million light-years in diameter, and within it are thousands of galaxies. As we travel farther, we reach the Laniakea supercluster, an immense gathering of galaxies extending over 500 million light-years. Laniakea, meaning immense heaven in Hawaiian, lives up to its name, containing the mass of 100 million billion suns. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a massive gravitational pull on the galaxies within the supercluster. In this vast expanse, our Milky Way, the Local Group, and even the Virgo supercluster are tiny components of this gigantic structure. Laniakea provides a profound context for our existence, reminding us that we are part of something far greater than we can fully comprehend. As we reach the boundaries of our cosmic exploration, we encounter the limits of the observable universe, an astronomical marvel stretching about 93 billion light-years in diameter. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in cosmic expansion. The universe has been expanding since the Big Bang, stretching space and increasing the distances between celestial bodies. Subscribe now, and let's explore the facts together.